Hello and welcome back to another video. In this problem, you're told if you invest X dollars at 4% interest compounded annually, then the amount A of X of these investments after 1 year is A of X is equal to 1.04X. We're asked to find A of A, A of A of A, and A of A of A of A. We're asked what do these compositions represent, and to find a formula for the composition of n copies of A. So let's find these compositions first up. So this notation A of A just means A of X. This is equal to A of, well, what is A of X? 1.04X. And now we plug in this into A. So instead of A of X is equal to 1.04 times X, we have A of this thing is equal to 1.04 times this thing. Right? And I'm using the language, right? A of this thing is equal to 1.04 of this thing, because what we're just doing here, and we're going to be doing it a lot of times, is just finding a new thing to plug into A. And so here, that's 1.04 times 1.04, 1.04 squared times X. Next up, we have A of A of A, which is A of A of A of X. And here, if we don't forget one of our parentheses, this is A of, we see A of X here. This is the thing we just calculated. So this is A of A, which we found is A of, plugging this in now to A. Like I said, we're just plugging new things into A. 1.04 squared times X. All we have to do here is now plug this in for X in A. So this is 1.04 times this thing, 1.04 squared times X. This is equal to 1.04 times 1.04 squared, 1.04 cubed times X. Our last composition that we have to do, A of A of A of A of X, is again A of, if we look here, what's inside the largest A, it's just the thing we just calculated. A of A of A. So this is A of 1.04 cubed X, since that's what we just calculated. Plugging that in, it's 1.04 times 1.04 cubed X, which is 1.04 to the fourth X, right? You're probably seeing the pattern here. 2 compositions is 1.04 squared X, 3 compositions cubed, 4 compositions to the fourth, n compositions, right? A, N, A, right? Which is n of these A's all composed, is equal to 1.04 to the n times X. What do these compositions represent? Well, our original function, we're talking about an investment, right? We're investing X dollars and it's compounded 4% annually. It's 4% of the original value. So if we invest $100, we're going to get 4% of that, which is $4, and we're going to get $4 every year. What this is doing, it's taking the composition of the function, which means we're taking interest on the interest. So therefore, we're not just getting, right, 0.04 plus 0.04, right? We're getting 0.04, yes, plus whatever this is, right? I think it's like 0.576, something like that, right? We're getting this, and then we're getting something else, which is even a little bit more, and then a little bit more, and so on, and the interest is going up over time. So instead of taking interest on the original value, we're taking it on the last value. So for this ANA, this is taking interest for n years. The original value is X dollars, but every year you're not taking interest on that X dollars, you're taking it on the previous value. That is what these compositions represent, and these are the compositions that we found.